Welcome, everyone. Today we're going to explore a tool that, you probably last saw in a high school algebra class, but it's actually one of the most powerful concepts in the entire world of business, the quadratic function. Now, I know what you might be thinking, but trust me, by the end of our time together, you're not going to see this as some dry formula. You'll see it as a secret weapon for making smarter and way more profitable decisions.
So let's just start with a big question. How can a simple curve, this U-shape that we call a parabola, literally be the difference between a thriving business and one that fails? I know it seems abstract, but think of this curve as a map. It's a map of the real-world relationships that drive commerce, showing us that really delicate balance between price and revenue, and between production and cost. And that really is the key. This curve is the hidden logic behind some of the biggest decisions a business can make. When a company is trying to set the price for a brand new product or decides exactly how many units to manufacture, what they're really trying to do is find the absolute peak of this curve. So today, we're going to give you the tools to not just understand this curve, but to totally master it.
Okay, let's dive right in. Our first section here is the parabola of profit. Before we can really put this tool to work, we've got to understand exactly how it works. We're going to explore why this specific U-shape shows up so often in business and what it can tell us.
So here's the formal definition. A quadratic function is just an equation that looks like this. Y equals ax squared plus bx plus c. Now the key ingredient, the part that gives it all its power, is that x squared term. That little 2 is what takes a straight, predictable line and bends it into the perfect symmetrical curve of a parabola. In the business world, y is almost always the thing we're trying to maximize, like revenue or profit, and x is the variable we can actually control, like the price we set or the quantity we produce. Now this is where it gets really interesting. Every single parabola has a turning point. We call it the vertex. It's either the highest point, a peak, or the lowest point, a valley. In a math class, it's just a coordinate on a graph. But in business, it's everything. The vertex is the point of optimization. It tells us the exact price we should charge to get maximum revenue, or the optimal production level to get the lowest possible cost. It is the answer to the single most important question: what is the absolute maximum profit we can achieve? So, how do we find this magic point? Well, it's not a guessing game. There's a simple but incredibly powerful formula for it. Take a look. X equals negative b over 2a. Seriously, that's it. All you have to do is look at your quadratic function and identify the a and b coefficients. That's just the number attached to x squared and the number attached to x. You plug them into this formula and boom, it spits out the exact x value for your optimal price or quantity. It is that straightforward.
Theory is great and all, but let's see how this thing actually works in the real world. We are going to walk through a case study for a brand new coffee shop and use our vertex formula to solve a classic business problem: how to maximize revenue. So let's meet our company, a new coffee shop. We'll call them Artisan Roast. They've got a fantastic product, but they're facing a challenge that every new business faces. What is the right price for their coffee, right? If they set it too high, they're going to scare away customers. But if they set it too low, they're just leaving money on the table. They have to find that perfect price point. Every smart business decision has to be based on data. So Artisan Roast went out and did some market research, and this is what they found. As you can see, it's pretty clear. As the price goes up, the number of sales goes down. This is a perfect example of that economic principle we call the law of demand. And this tension, this push and pull between a higher price, bringing in more money per sale, but resulting in fewer sales overall, that is exactly what creates the parabolic shape of a revenue curve.
Okay, so now we take that data and turn it into a function. We all know that revenue equals price times demand. Now, using a statistical technique called regression analysis, which you'll study in more detail later on, we can find the quadratic equation that best fits our data points. And for Artisan Roast, that equation is r of x equals negative 50x squared plus 500x. This is now our powerful revenue model. It's a mathematical description of how their income is going to change as they adjust their price.
And now the big question: what price is going to give us the most revenue? It's time to use our vertex formula, x equals minus b divided by 2a. Okay, so in our equation, the b term is 500, and our a term is negative 50. So let's just plug those in. We get x equals negative 500 divided by 2 times negative 50. The denominator, 2 times negative 50, that becomes negative 100. So we have negative 500 divided by negative 100. The negatives cancel each other out, and we get x equals 5. So according to our model, the price that will maximize revenue is exactly $5. Okay, so that's the price. But how much revenue will they actually make at that price? Well, to find out, we just plug our optimal price, $5, back into our revenue function. So R of 5 equals negative 50 times 5 squared plus 500 times 5. Let's do the math here. 5 squared is 25. Negative 50 times 25 is negative 1,250. And 500 times 5 is 2,500. So we have negative 1,250 plus 2,500, which gives us a maximum daily revenue of $1,250. This right here, this is the very peak of our revenue parabola.
Great, so we found the price that maximizes revenue. Now, this is an absolutely crucial point. A lot of students, and frankly a lot of actual businesses, would just stop right here. But that is a huge mistake. Maximizing your revenue is good, but it's not the ultimate goal. We have to factor in costs to find the number that truly matters, profit. So let's move on to our next section and see exactly how to do that.
I want you to burn this quote into your memory. It's a classic for a reason. Revenue is vanity, profit is sanity. It is so tempting to focus on bringing in a ton of revenue. It makes for great headlines, it feels good, but if your costs are out of control, you're not actually making any money. You could be selling $1 million worth of product and still go completely bankrupt. This is probably the most important concept we are going to discuss today.
Let's be crystal clear about the difference between these two goals. Revenue maximization, that's all about the top line, how much money is coming in the door. Profit maximization is about the bottom line, how much money is left over after you've paid all your costs. It is so easy to get caught up in chasing revenue, but that can lead you to make decisions that actually destroy your profitability. The key takeaway here is that the price that maximizes your profit is almost never the same as the price that maximizes your revenue. All right, let's bring costs into the picture for Artisan Roast. Let's say their cost function is C of x equals 100x plus 200. Okay, what does this mean? The 100x part, that represents their variable costs. These are the costs that go up with each cup of coffee they sell, right? Like the beans, the milk, the cup itself. And the 200 represents their fixed costs. Things like rent and salaries that they have to pay every single day no matter how much coffee they sell. And now we can finally create the most important function of all, the profit function. It's simple. Profit is just revenue minus cost. So P of x equals R of x minus C of x. We'll substitute in our two functions, that's our revenue function, negative 50x squared plus 500x, minus our cost function, 100x plus 200. Now be very careful here. This is another spot where students often make a mistake. We are subtracting the entire cost function, so you have to distribute that negative sign to both terms inside the parentheses. When you do that, you get negative 100x and negative 200. Then we just combine our like terms, and we get our brand new profit function. P of x equals negative 50x squared plus 400x minus 200.
We have a new parabola, which means we have a new vertex to find. So let's use our vertex formula one more time, but now with our profit function. Our A term is still negative 50, but look, our B is now 400. So x equals negative 400 divided by 2 times negative 50. That's negative 400 divided by negative 100, which gives us x equals 4. So the profit maximizing price is $4. I want you to notice that. It's a full dollar less than the revenue maximizing price.
And what's the maximum profit they can make at this new lower price? Let's plug $4 into our profit function. P of 4 equals negative 50 times 4 squared plus 400 times 4 minus 200. Okay, let's calculate 4 squared is 16. Negative 50 times 16 is negative 800. 400 times 4 is 1600, so we have negative 800 plus 1600 minus 200 for a maximum daily profit of $600. This is the true sweet spot. At $5, sure, they were making more revenue, but their costs were also higher, and it was just eating away at the bottom line. At $4, they found the perfect balance to maximize their actual take-home profit. So we've found the mathematically perfect price. But as we all know, the real world is a lot more complicated than a mathematical model. So in our final section, we're going to put on our manager hats and think about how we use this model to make smart, strategic decisions. There's a famous quote by the statistician George Box that I really want you to remember. All models are wrong, but some are useful. What he meant by that is that any model, including the one we just built for Artisan Roast, is a simplification of a messy, complex reality. It's never going to be perfect, but it can be an incredibly useful tool for making better decisions. And this is a perfect illustration of that point. Our model is a great tool, but of course it has limitations. For example, it assumes that demand is perfectly predictable. But what if a competitor opens up right across the street and starts a price war? Our model doesn't account for that. A good manager uses the model as a starting point. They'll say, okay, the math tells us $4 is our optimal price. But now, What other real-world factors do we need to consider before we make a final decision?
So, what is the big takeaway from all of this? As a future business leader, your job is to be the bridge between the numbers and the real world. You use these models to get the data, to get the insights you need, but then you use your own judgment, your experience, and your awareness of the market to make the final call. The math should inform your strategy. It should never dictate it.
And so I'll leave you with one final question to think about. You've done the math, and your model says that $4 is the perfect price for Artisan Roasted's coffee. But before you go and launch with that price, what's the very first real-world factor you would want to consider? What is the first question you would ask in that management meeting? Answering that question, well, that's the first step from being a student to becoming a strategist.